Hello. Can you hear in the back? Amazing, fantastic. Hello, I'm also Ben. So I'm the manager of the named here. I'm the founder of Pseudoblock, a multidisciplinary software engineering consultancy based here in Manchester. I actually done my first ever public speaking event in this room about a year and a half ago, so that's lovely. And other Ben was in the crowd, so there it is. Hey. Today I'm going to show you how you can integrate a fission inference pipeline into your serverless architecture without the need for any ML specialists or any kind of specialist infrastructure. I'm going to do this with a live demo. So we're going to build a app which allows you to extract book metadata, thanks for crossing the fingers, book metadata from book images. So the idea is you can take a picture of a book and from that you can extract metadata about that book and build up a centralized data lake of all the books that you have. There's a QR code there which will take you through to my website. So tomorrow, via LinkedIn, I'm going to publish the code for it. So the demo that I'm going to show here, the code will be live tomorrow. And then next week, just because there's only so much I can do in 20 minutes, I'm going to do an in-depth technical blog post on this serverless architecture, going into the real nitty-gritty and things that I can't cover in 20 minutes, like trade-offs and best practice and how to productionize it and all that other sort of good stuff. So yeah, has that gone? Yeah, it has. Let's imagine a problem. So if you're a library or a bookshop and you need to start to make a centralized catalog of your books. Is that better? Yeah, a centralized catalog of your books. Say you've got about 400 of them and it takes a data entry specialist 2 minutes to extract things like a title, the ISBN, the author, a description, all that sort of stuff. If you're doing 400 books, that's about 13 hours of work. If you extrapolate that, the task gets bigger and bigger and bigger. The scaling goes off the charts, right? Now, you traditionally have two approaches to fix this. The first is quite simple. You hire more people. You get more people to do your data entry. The second is you can make a complex optical character recognition pipeline that can extract that metadata from the images for you. That requires hiring ML specialists. That requires creating ML infrastructure. You might start managing SageMaker instances. You might start training your own models, and that becomes very not only computationally expensive, but also expensive as an organization as you adapt to actually managing to work with proper data scientists. Now, what I'm going to show today is a different option, which is how you can take a bog standard serverless architecture that all your platform teams know, and you can plug AI inference from off-the-shelf foundational models into that in order to achieve this sort of functionality. So here's the serverless pattern. So it's a bog standard architecture. It shouldn't really come as any surprises. You've got, in this instance with the demo, we're going to upload a zip file of photos into a landing bucket. That's going to trigger a Lambda that will unzip it and extract each individual photo into a raw bucket. That will trigger another Lambda, which will use Bedrock to run inference to try and figure out what the metadata about that book actually is. We're then going to use Pedantic to do some validation. That's purely because my primary language used to be C#, but is now Python. And so Pedantic is what I like to use to validate things, but take your pick. And then we're going to store that in Parquet, and we're going to run some Athena SQL queries to see what that metadata looks like. However, your platform team knows this architecture. It's fairly standard and straightforward. The thing that I want to emphasize, though, is that this event-driven serverless pattern isn't unique to AWS. I'm not here to sell you AWS. I'm here to talk about an idea. So as you can see on this slide here, each of these individual components, such as the object storage, such as the AI inference, all the major cloud providers will give you components you can lift and shift to do that. And crucially, the output of that, which is Parquet, which is a columnar format, is completely vendor independent, and all the big analytical engines support it. So if you use Athena, BigQuery, Synopsys, I think, is the Azure one, or if you use Databricks or whatever, they will all support that. And in fact, this pattern that I've given here, yes, I've given you all the examples of how to do it on the cloud, but you could do this just as easily on-prem if you have your own architecture you can start to use things like LM Studio or OpenAPI APIs to start doing your inference, and the fundamental architectural patterns stay the same. So the reason I'm standing here and not wandering about like I normally do is because we're about to do a demo. So we're going to upload 40 book covers. We're going to watch the lambdas process them in real time from the unzip to the inference. And then we're going to see how Bedrock extracts that metadata, and then we're going to actually query that with Athena. So tomorrow, like I said, the code will go live. There's a URL there for the actual GitHub repo, which will go live tomorrow. And I'll do a little LinkedIn thing about it tomorrow as well. But without further ado, let's do a demo. Let's hope it works. I like that nervous tapping on the legs there. Thank you.
It was meant to be a drum roll.
It was meant to be a drum roll. Okay. Well, that's perhaps more optimistic, I think. Right. Is my screen mirroring? Because I can't quite see the telly. Cool. So, first of all, let's have a look at. Oh, actually, is this viewable? Do we need to zoom in? I'm seeing some.
With binoculars.
How about now?
Yeah.
Amazing. Do you still need the binoculars? No. Okay. So let's have a look at some of the raw data. That's me. You can start judging my taste in books. We've got Fahrenheit 451, excellent book. We've got Philip K. Dick's The Penultimate Truth, also an excellent book. The Census Taker, excellent book, only 100 pages, so you've got no reason not to read it. And 1984, also an excellent book, though the ending scarred me. What I've also got here is, and this will be in the, not the images, you're not going to get images of me in the repo. What you will get is a shell script here, which will go out to Open Library and pull down X amount of images. In this instance, I've got 40 with 5 of my own. So you can see if I click here, these are just random images from an open library that I've downloaded to prove the concept. So let's follow my demo and see if I can do it one-handed. So let's. So I've got my book zip at the, oh, that was a bit loud. I've got my book zip at the root there. We are going to use the AWS CLI to automatically discover what my landing bucket is. And then we're going to upload it into S3. Once that hits S3, we're going to follow some logs, although based on my notes, I might change this later, from the excellent previous talk about seeing the, I mean, that's gone so quickly, I can't even show you it. Let me go here. You can see that we've processed 45 images there into individual files, and we have extracted each of them into the raw bucket. So that's from the landing to the raw. In prod, you would probably, before you get out of your quarantine landing site, do some kind of AV and whatnot to make sure someone hasn't given you some dodgy data. And now we can see the extractor. If I can type one-handed, which I can't. There we go. So there are some errors in here, as you can see, and I've put these in here for a reason I'll come back to later. But we'll see that the there we go. We can see that we are successfully extracting metadata from the image, and that we're saving it as Parquet in our final bucket. Now, the way that this works, before I show you the SQL, is really quite simple. So those of you who've come to other talks of mine will know that I like using data-driven Terraform. The patterns I've done previously work very well for large enterprises, but I found that when you move into smaller teams, and when you start to get people using things like AI chatbots, it doesn't work as well with it. So I've come to a sort of a new model which uses a centralized data model to define all of it. I'll do a talk or a post about that later, but we can see in the lambdas here we simply have an unzipped processor and a metadata extractor, which as an mvar takes our model. In this case, we're using Claude 3 Haiku and a bunch of stuff. I won't show the unzipped lambda because that is incredibly uninteresting, but I will show the metadata one. So first of all, you can see that I like type checking. We can see the root inference is relatively simple. We've just got a prompt where we're telling the agent to return to us from the image JSON. And then we're also using some rules to make sure that that actual output conforms to certain rules. Now, if we go a little bit further down to see the actual handler, we'll see that when we process that image to Parquet, we actually transform the image. We use Pillow to reduce the dimensions of that image to trend 24. Then we base 64 encode that image, and we include that in the prompt to the model so that it has knowledge of the actual image itself. And then we use that prompt to get that output. You can see in the extraction here, we've got the resize, and then we've got the base 64 encode. And in this particular model, because it's a anthropic model, we're just passing through to say, look, this is your image here, this is your base 64 encoded image, this is your prompt, go. Now, those of you who've been around as long as I have may have heard of Bobby drop tables. Now, the same principle applies to LLMs. You can't particularly trust their output, they'll give you anything. So there's a 3-tiered approach that I've used here in order to actually validate that output, and this comes back to the fundamental data engineering that never particularly changes. So I'm using Pedantic to validate the output here. So I've got things like title, author, ISBN, etc. But what you can do with Pedantic as well is some data normalization. So here, for the ISBN, for example, I'm removing spaces and any hyphens to normalize that. And for the publish year, I'm ensuring the date is within a certain range. Now, historians among you will tell me that the Epic of Gilgamesh was 2000 BC. We're not including that in this example. Don't come at me for it being 1000 AD here as a constraint. So, how do we actually take this output from the model and turn that into Parquet? He says, scrolling down here. Here we go. So we've got a 3-tiered approach to passing the output from the model. The first is we just assume it's given us the JSON. And you can see here on line 367, we try to pass that into our Pedantic model to actually validate that output. And if that works, great, we've returned that data cast through to a dictionary. Perfect. What if that fails? What if we can't decode the JSON? Well, potentially the model might have given us something helpful, like, hello, I'm a model, here's your response, and then given us the JSON, which is not what we told it to do, but it might do that. So in this instance, we simply do some string finding to find the first index and the last index of a curly brace, and then we extract that, and again, load that into our Pedantic model to then validate it there. Now, if all of that fails, so the model hasn't given us JSON and it hasn't given us JSON in the text message, we fall back to some default data so that the workflow still goes, but we log an error. And then this is where in the post I'll go into next week, because I don't really have time to cover it, you can put in dashboards and alerting and whatnot so that you can go, oh, well, actually, I've got 10 images that I processed in the last minute that have used defaults. Something's probably up with my prompt or my model or my architecture. I need to go and I need to fix that. So without further ado, I've shown you all of this, and you're kind of trusting me that it's actually produced some output. So we should probably check this, produce some output. So if we go through to my AWS account here, oh, actually, I shouldn't do that. Once the Parquet is in an S3, we need to run a glue crawler to actually discover that data and index it into a SQL-like format. So those of you who don't know Glue, sort of traditional data lake architecture, you can use Glue to discover your data. In this instance, we've Hive partitioned it, so we've partitioned it by, that is not, oh my goodness, that is awful, hold on. There we go. To hive partition the data, so what that means is you can query by year, month, and day of the ingestion. Now, if you can partition your data, a data lake model such as this is great. If you can't partition your data, say you've got transactional versus reference data, then you may have, say, a reference table that sits outside the data lake that you then append to on the basis. So a good example might be you might use IDs in the records for authors, and then you might have a singular DynamoDB table that looks up IDs to author names, for example, right? Now, this glue crawler has started. Now, if we go through to AWS, and this is where my session's timed out. Oh, it hasn't. Oh, excellent. We can see a glue crawler is currently running to discover our files, and in fact, it completed in 49 seconds, so that's clearly planned. And we can now go to Athena, if I go to the right tab. So we can query, for example, based on what books I have by the author. So you can see here, Philip K. Dick wrote The Penultimate Truth. That's great, I can query that with SQL. This is in the wrong order. I can get a list of all my publishers and sort of how many books I have by that publisher, for example. I can also do something nice where I can see, okay, I've got these authors, we've got these books by them, this is their earliest book, this is their latest book. This is the confidence, so this is where you can, in this demo, I've just given the confidence that the model has given me, but in an actual production environment, I'd probably have some kind of algorithm I've written myself to go, this is the data output, based on the quality of this data, I am X% confident on this actual output here. And again, that's where in the production environment, you can put in place dashboards and whatnot to then go, oh, actually, we've got 50 outputs in the last day with a 10% confidence. That's bad. Let's go fix that, for example. We've also got some data quality metrics, though my Athena tabs are all in the wrong order. So you can see we've got some basic data quality here, where we've got 33 unique IDs. We've got 3 duplicates. That's probably bad. And some various other data quality metrics here based on the data. But all of this is just from me uploading a SIP of a bunch of book covers, which is pretty good. So let's resume. Now, I don't know if this will... The TV's smart. There we go. So some key things to take away from this. The whole demo, the whole pattern is event-driven. It's just standard serverless stuff that you know already. There's no sort of magic black box AI shenanigans. It's just serverless architecture. Your platform team already builds it. They already know how to use it. There's no need to do any machine learning. You're just doing inference. Secondly, pedantic validation. You can't trust the output of LLMs, just like you can't trust user input. So always have some kind of validation. I chose pedantic, and when the code goes live, you'll see a pedantic version of it because that's what I'm comfortable writing. Whatever your language, whatever you know how to use, always validate your outputs, otherwise you might get a Bobby drop tables. And Parquet storage. So the usage of Parquet in this is to be vendor independent. It means that I can take those outputs, and if I'm talking about a traditional data lake, data warehouse model, it means that my data lake can output stuff in Parquet, and that's great, but then I can plug in a warehouse that lives in a completely separate cloud environment, and it will just work, because all of these solutions work on Parquet. So it doesn't tie you in. Or say you've built this in AWS, and suddenly Azure turns around and gives you a load of credits, you can just port it all across to Azure because it's now 20% cheaper. There's no problems here. Your data is completely interoperable between any major cloud provider, or even third parties like Databricks, or Snowflake will just plug straight into it. So those are the key patterns that have enabled us to do this. Some key takeaways. The first is that if you're just doing AI inference, all you're doing is trying to use an off-the-shelf model to drive some kind of valuable insight. You can probably do that with some kind of serverless architecture that your platform team already knows. The only thing that changes is in whatever computational step you have, you're just doing a call to some kind of SDK to call an AI model. But you know, your team already does that. They call weather APIs, they call database APIs, they call whatever. It's just another API call under the hood. Pedantic validation prevents garbage in this instance, although take it to your own language, your own frameworks, whatever validation you need to do to prevent garbage coming out of the platform, do that. And the third, the usage of Parquet storage in this is completely vendor independent. It means I can produce outputs on AWS and then analyze them in Azure, or I can do it on my own homebrew system, running in my shed, and then I can plug Snowflake into it and it will still work just as fine. So like I said before, the demo code for this will all go live tomorrow, and the link is up there for it. And if you scan the QR code and go to Pseudoblark's website, we'll also be doing a LinkedIn post to make that code live. There will also, like I said, I'll be doing an in-depth technical write-up on this pattern, going more into the trade-offs, more into how you can productionize this. For example, and this is why I included it, you saw that we got some back-off errors in the log for the processor Lambda. Now that's because there are limits in AWS for how many times you can invoke one model within a minute. We had 45 images. That's on purpose because the limit is 40. So it failed. Now, if I was to productionize it, and the blog post goes more into this, you would probably put some kind of back-off loop, some kind of retry. If you're orchestrating this, for example, via a queue system, maybe you put some kind of delay so that events only pop off your queue in a certain manner. If you do have any questions, just like I want to say Ben one, because you went first, said, you can talk to me after the event. I will be hanging around. Equally, you can contact me on hello@pseudoblark.com, or if you go through to the Pseudoblark website, I'll have details linked in the Pseudoblark, and you can contact me there. Questions? Hello. I'll go you first and then you second, sir.
Thanks, I really enjoyed that. I'm curious, the exception you get there to retry the JSON parsing, what's the rate of you need to do that? Did you test that? How successful it is at first time versus model dependent, presumably?
Yeah, so yes. I begun answering it, so my brain short-circuited. Can you repeat your question, then I'll repeat your question, and then I'll answer it.
Better than I did, but you've got that exception where the JSON decode, and then you retry searching for the start and end.
Oh, yes.
For the brackets, for the JSON start and end. Just curious how often that happens and what the success rate is. Presumably it changes depending on the model.
Okay, so the question was, in the pedantic validation, we had a three-stage process. The first was to try and load up the output, but then there was a fallback where if the model gave you something that wasn't the JSON you asked it for, to then try and have some kind of different logic to try and actually extract the data we want to learn about. And the question was around what is the success rate or the failure rate of that, and does that differ between models? I'd say yes. So I done this specifically with Claude 3 Haiku because it was the cheapest model I could find. So the feedback, but to be fair, with Haiku, I didn't get that. But the thing is, it's a matter of following, right? If you do these models a lot and a lot and a lot, you will get some kind of faulty output. Unfortunately, because it's all running on my own infrastructure, I didn't do any kind of like extensive load testing to figure out the difference between the models. But if you wanted to, I think it's cost me about 20 cents to do a month worth of testing on this before today. So it's fairly cheap to do that. But unfortunately, I can't answer you with hard like percentage rates, unfortunately.
Thanks.
Cool. And you were next, sir.
Did you say you were pulling the ISBN number? Because the ISBN number is normally on the back of the book.
Yes, so that is something where this demo that I've done, because I like reading books, you have pointed out quite correctly. Oh, sorry, I should repeat the question. The question was how you put in the ISBN number on the front of the book, because normally they're on the back. That's perfectly valid. So within this one, the AI tries to look it up from its own knowledge base, and that will be liable to fail because it's only got the knowledge that is in there with. Now, you're quite correct. If this was a production book app, maybe you'll get someone to take a picture of the front and the back, or maybe you could have some kind of, and this is where having data in this modular format, and this stuff never exists in isolation, it's always in an ecosystem. Say you scanned a barcode or you took a picture of the ISBN, you could do that, or you could have some kind of third-party lookup to go out to an API and look it up. But in this particular instance, you are correct. The much more simpler answer is
just look up the ISBN.
It's on the back of the book, yes.
Well, on the ISBN, there's plenty of databases that will swap you between the ISBN and this. I know
Mm.
we're doing this for effect. But,
Mm.
and the other question is, I understand all the Parquet stuff, but why not just stick the JSON into Dynamo?
Yeah, so you absolutely can stick the JSON just into Dynamo. So I should say, why all the whole question thing? Why are you storing it in Parquet? Why are you not just sticking the JSON into Dynamo? That is true. You could stick it just into DynamoDB. It depends on the use case. The reason why I put it in Parquet and S3, for my sins, the last 3 years, I've been making a lot of data lakes for clients, and the setup for a data lake in AWS is to utilize Parquet in S3 so that you can then plug in warehousing systems to do some kind of analytics on there. In this instance, it means you can take that file and you can put it through some kind of analytic warehouse or do further processing on it. But if this was, for example, just an app to do books, and you wanted to just store your books, you wanted a little thing on your phone to tell you what books you had, then absolutely, perhaps just storing it in Dynamo would be good. A really good example of it would be a client of mine whom I can't say, but I built something similar to this for them about 1.5 years ago, and the backend solution for that was DynamoDB. So it depends on the use case, case-by-case basis. S3 is quite cheap. DynamoDB is also quite cheap. It depends on your use case. For me, it was preference. That's the short answer. Cool. Any other questions? No? Oh, thank you very much. Okay.
Hi guys, thanks for coming today. We're going to head to the Seven Brothers pub. Seven Brothers? Think about? Round the corner, somewhere around there. Yeah. We'll be there after the meetup. Thank you to Ben and other Ben as well for the talk. It's a very good talk today. They'll work on YouTube next week on Friday, by the way. So yeah, have a look on YouTube. Yeah, thank you.
Thank you. Cheers. I'm glad you enjoyed it.
I'm Ben as well.
Oh, you're another Ben? Oh, no!